Of a differential equation, and I will write in blue because red is okay, it's a good one. So our differential equation is y prime is equals to x minus y. So I will define everything in a different color. Now we have a law of indice, so we use a law of indice here. That's the first part, which says a to the power m minus n is given as a to the power m dot a to the power negative n, which is am over an, like this. So we are going to use this law of indices where here. That's what we are going to use. So let's do it now. So y prime is equals to x dot negative y. But you should know that y prime is actually dy over dx. So y dy over dx is equals to e to the power x divided by e to the power y. Now, what are we going to do? Separate the terms. So we are going to separate the x and the y on each side, So we take what is y, what is x, and on each side. I'll do it slowly to help those to see what is happening. So I have got y here, and dy is equals to ex over ey dx. So I'm left with this. I take it that side, y ey dy is equals to ex dx. So here, this stage, we introduce integration. Introduce the integration. Introduce the integration. So what are we going to have? We are going to say, if we are going to introduce integration, the integral of y I'm used to x, ey dy is equals to the integral ex dx. Now, according to the integration rule, so the law of integration, I don't know whether we could call it the law of integration, or there are some identities in integration, which says if you integrate e to the power x dx, you get e to the power x plus a k. Now, what are we going to get? What are we going to get? We are going to say the integral y e to the power y dy is equals to e to the power x plus a k. So in this case, if you look at this side here is equivalent to the integral of integration of u dv is equals to uv minus the integration of v du. So this is the general rule by parts. So we integration by parts. So we are going to choose our u to be what? So if we are going to choose, we will say, let our u be equals to something that will quickly disappear, y. We differentiate it, du over dy, we get a 1. And we come here, definitely our dv over dy is actually equals to ey, right? Because ey, for those who can see, the ey, if you take this part here, it's gonna be the dv. If you take this one here, it's gonna be your u. You see, that's the idea. Then if I integrate this part here, I'll definitely get ey again. Ey will come back again. So what are we saying? We are now saying that if we use the rule there, we are now saying that our uv minus the integral of v du should be actually now be your u, it was a y, our v is actually a ey now, minus the integration of this. In other words, even if I write it like the integration of ey and I write dy like this, then it's gonna be much easier. So it's gonna be much easier because we are going to write ey minus ey is equals to ex plus a k. Now we can factorize because we have this which look common. So in other words, I will have y minus 1. Pull it outside, ey is equals to ex plus a k. So if you do that, this will be our solution, our answer to the differential equation. So for more work, follow me on YouTube and like and subscribe. Thank you. If you have a comment or you have something that you want to debate, let's meet in the chat. Thank you.